Hello everyone, it's me, Mr. Casilli, talking about 6.4, Applications of Similar Triangles. We're going to be talking about two new methods that help us figure out if lines are parallel or some missing sides. So the first one we're going to go through is called the side splitter theorem. A lot of you have already actually picked up on this one already. It's called the triangle proportionality theorem, aka side splitter. We call it that because we're literally comparing the two split sides of a triangle marked by parallel lines. So a line intersecting two sides of a triangle is parallel to the third side if and only if the line divides the two sides proportionally. We see that right here. So for example, let's say RT was 8 and this was 4. If this was 10, what would US be? If you said 5, you get this. Proportionality means those fractions will equal each other. So, what I want you guys to do is I want you to write down the following on top of the proofs right here. There is a large proof below this. I'm going to give you a printout of that tomorrow to save some time. For now, just make sure you have the diagram, the given, and the proof part itself. Again, do not copy this. If you would like to copy it tonight, again, I'm going to give a printout tomorrow. I'm putting it on the screen right now. Feel free to pause your video. Basically, this is a whole proof for showing why the side splitter works. Once we know this, we can use it every single time. So again, do not worry about copying this down tonight. The more important notes are on the back page of this. So, moving on to the back page, we're also going to add in a theorem called the angle bisector theorem. So the angle bisector theorem is a little wordy, but it makes sense when we practice it. So an angle bisector is a triangle divides the opposite side of a triangle into two segments whose lengths create a ratio equal to the ratio of the lengths of the adjacent side of the triangle. Wow, that's a lot. But look at this. What it's really saying is that CD over DB will be the same proportion as CA over AB, aka the angle bisector theorem. This is only true when these two angles are equal to each other. So for example, if we had a diagram like this, and I had one side that was 5 and one side that was 15, and this part was x and this part was 9, I could say side over side is equal to side part over side part, just like we see here. And if I solve that, I get 3. So look at that proportionality. 15 over 5 is the same as 9 over 3. Make sure you have the example down. We're going to do plenty more in class. Before you remove the thing to the bottom, try out the bottom questions either on a scrap piece of paper or looking through it, and then compare your answers to mine. For the first one, they end up not being parallel. Did you get why? Look at your fractions. 6 over 3 is not the same proportion as 7 over 4. So the side splitter theorem does not work. Therefore, even though it looks like it, these two lines are not parallel to each other. Because they're not parallel, we can also show that these two triangles are not similar to each other because these angles won't be corresponding. On the right-hand side, a little more involved. We're first going to label this part as 15 minus x, because if this part's x and the whole thing's 15, this part can be 15 minus whatever this is. And now we're going to use the angle bisector theorem. 7 over 13, side over side, equals part over other part. If we solve this, we get 9.75. Now, we can check this work. 7 over 13 ends up being the same exact, oops, sorry about that. Feel free to make fun of me tomorrow for that one. 7 over 13 is the same ratio as 5.25 over 9.75. So again, the ratio of the side to the side is the same as the side length here to the side length here, as long as these angles are equal to each other. So I know the math, there's a lot of numbers today. Feel free to pause as necessary. You guys have a great day, and I'll see you tomorrow.